The keynote speaker for the session is Professor Dr. Mohammed Daud. Dr. Daud is a Harvard-certified higher education teacher, currently working as a professor in the Textile Engineering Department at NED UET Karachi. He is an active researcher in the field of smart textiles, soft robotics, and Industry 4.0. I welcome Professor Dr. Mohammed Daud to the conference and request him to join us on stage to share his research on demystifying the design process towards the development of textile-based sensors. Thank you.
Assalamu alaikum, and a very good day to all of you. And thanks for the introduction. I would also like to thank the organizing committee of National Design Conference for the invitation. So today I would be talking about the process to design and develop textile-based sensor. My educational and the research background is more towards engineering and sciences. So you may find my talk more related with the STEM, but I would be speaking about textile materials, textile structures, and the products in the form of garments. So probably the textile designers and fashion designers, they can well relate to it. So it will be a challenge for me actually to to deliver a technical talk in front of artists and designers, and that's within 10 minutes. So I'll try my level best. But if you find it that is too technical, so pardon me in advance. So that's the outline of my. I'll give you just briefly an idea about what is E-Textile and textile sensors, then the process to design and develop the textile sensors, and what are the different parameters which we need to consider, and what are the different methods to impart the conductivity in textile substrate. And then I will focus more on the knitted sensor parameters. And then I'll explain by giving three examples, three different types of textile sensors. That includes the ECG sensor, respiration sensor, temperature sensor. And depending upon if I have time, I may discuss what are the current challenges in developing the textile sensors. Right, so sensor is basically we use in everyday life. We have got sensors in mobile phone, we have got sensors in our vehicle, we have sensors in many different appliances we use at home. So we cannot even think about living in this century without sensors. The sensors have different application. One of the application of the sensor is basically the monitoring of the human body vital signs. And vital signs includes the blood pressure, the pulse rate, the respiration, and the temperature. These vital signs are quite important to diagnose and manage the disease process. E-Textiles literally means electronic textiles. It's the textile which is embedded with electrical and electronic functionality. And it is also known as electroactive textiles, intelligent textiles, and smart textiles. Wearable health monitoring system is a complete system having a textile-based sensing platform embedded with textile sensors and data acquisition system and a relevant app. For last couple of decades, a huge research in this area is going on, and people from across the domains like in electrical, electronic, biomedical, textiles, fashion, they've been doing research to produce a solution especially for the patients, for the general healthcare, to improve their quality of life and to reduce the hospitalization cost. So one of the components of this wearable health monitoring system is textile sensors. So my talk focus would be on the textile sensors today. Right. So the first step, if you're designing something, but let me tell you one thing, that the process of design is similar across the domain, be it's the mechanical engineering design, be it's the industrial design, fabric design or clothing design. The process is more similar. The first of all, you have to identify what's the problem to address and what is the application environment, because all the requirements would be generated from that particular problem and the relevant application. So this is the first step which needs clarity. And then we have to list what are the significant design parameters which must be taken in consideration and what are the non-significant parameters which may change depending upon the options we have. And then prototyping, testing and validation, production and commercialization. I will not going to talk because this is out of the scope of this presentation, considering the limited time I have in 10 minutes. So my talk would be more towards on the design parameters. So when we talk about design parameters, the first is basically the material. We have different types of textile material, conventional, modern, smart materials. And within conventional, we have like stretchable material, non-stretchable material. So we have to see from the application point of view and from the problem which needs to be addressed, that which material and the availability we have, the what material we can conclude. And the second option, we have to decide at which level we have to, inject the conductivity into the textiles. The second is basically the sensor geometry. Is it the square, in the square form, circular form? Is it in the form of inlay, or it is in the form of, courses? And the construction. Construction here means the fabric constructions, like it is woven or knitted. If it is woven, what kind of weave? Conductivity is coming in the warp direction or the weft direction. Similarly, we have different types of structures in the knitting. So this is another parameter which needs to be considered. And then sensor placement. Like ECG, there is a respective position where sensor has to be placed. And that is quite different from the respiration sensor. Similarly, for the temperature sensor, the position would be different. So you have to decide, depending upon the placement, the sensor should be designed accordingly. And then, of course, how the data would be coming, what are the power lines, signal lines, and how you will going to be included in the form of weft or warp or in the form of courses or rails. So that's a decision depending upon the kind of machine you have. And data acquisition system, this is basically designed by the electrical or electronics engineer. Another thing which I have to consider is biocompatibility, because sometimes people have these skin allergies and all that. So you have to consider that material which is easy to wear and comfortable as well. And then calibration aspects. And last thing is that, of course, durability and washability. So when you combine electronics and textile, so you have to compromise some of the properties. So durability, because we have to, since it's a textile, so you have to wash it. So what are the washing parameters and all that? So this is another important consideration. So how can, in order to make textile conductive, because if you're making a textile sensor, you have to make it conductive. So how to impart conductivity? So conductivity within textile fabric structure could be imparted at various levels. We can develop fiber having conductive functionality. We can impart the conductivity during the yarn formation, blending, twisting, doubling, or and the coating as well. And then we can add functionality at the fabric formation level. We have got weaving, knitting, and braiding, and even non-wovens as well. And then we can also impart conductivity when the fabric is being manufactured already, and then you are coating it with conductive inks or with the help of sewing or embroidery and all that. So from here onward, I would be specifically talking about fabric formation level, and within that, the structure, the construction would be knitted structures. And the last one is basically, this is basically the first generation E-Textiles, that when you directly purchasing the component from the markets and placing it directly on the fabric. Okay, so I mean, but still some people adopt that technology, but this is something which people were working 20 years back. So now at the fabric formation level and the yarn formation level, these are the methods which are more common nowadays. So within the knitted, when we talk about the knitted sensor, so we have to see what are the different parameters which need. So because all these parameters play a really important role. So the first is the material selection, of course, and then you have to see the yarn count. It's the availability and the machine, because yarn count and machine gauge, they are relevant to each other. So not all kind of count you can use on the machine. And then you have to see we have got different types of stitch types, stitch length, because with these slight changes, basically the characteristics of sensors changed. Okay, when the sensor characteristics change, its data acquisition capability and its usage and its baseline specification, it also changes. So all these parameters are quite important. And the type of knitted structures like single jersey, rib, interlock, PK and all that. And the very important parameter is stretch and recovery. In some textile sensors, we have the requirement of stretch, we need stretch. And in some applications, we don't need stretch. So you have to see that which kind of textile sensor actually you're making. And then there are special techniques like plating, intarsia and inlaying. I'm sure the textile designers sitting here, they must have studied this knitting designs and they must have made some different, because I've seen the machines over here, the Store and Chima Saigi. Right, so just give you a brief idea about the ECG sensor. So ECG sensor, basically the placements of these sensors is coming from the Eindhoven triangle, which you can see on the top right. And then you can produce the front panel of the shirt or individual sensor on any flat bed knitting machine with exact positioning of the sensor. So minimum we need 3 electrodes. So the conductive electrode would be, of course, you need conductive yarn. And for the non-conductive area, you would need conventional yarn. For example, the cotton or polyester and all that. And from the sensor point of view, we don't need stretch and recovery in it, because if the knitted electrodes keep stretching, during human body movement, then it will affect the signals. So we need a very stable structure like the interlock structure, which is all the time having close contact with the body. So this is really important. This is just the data acquisition. Like what kind of, how would you like to acquire the signals? On your mobile app, on your laptop. So you have to consider relevant wireless technologies, and you can process the signals within your app, or it can be processed in the electronics circuitry. So there are different options available. The second is respiration. So the design of a respiration sensor is quite different to ECG. So in ECG, we need patches in circular or rectangular form. In respiration, it's more like a strain sensor. In this, we basically knit conductive courses, okay? And these conductive courses should not make contact with each other. So if I'm not sure if it is working or not. I think flashlight is not working. Right, so the idea is that basically when you are using conductive yarn in the single jersey course, in normal situation, the conductive yarn loops are in close contact, okay? But when you stretch it, these contact points will be no more, and that will affect the flow of current, that will affect the resistance properties. So by this stretch and non-stretch, you can have the change in the resistance, and you can detect that resistance, and that can be used, basically to detect if we have got a respiration. And for respiration, keep in mind that either we can place it on the chest or we can place it on the tummy. Both options we have. So when we breathe in, so this area would be slightly expanded. When we breathe out, the tummy area would be slightly expanded. Okay. So the placement of strain sensor would be quite different when we compare that with the ECG sensor. For temperature, basically the construction technique is different. Here you can use a sensing element, which could be a conductive yarn, or it could be a conductive wire, and you have to, basically insert it by using the inlaying technique. You should not be inserting as a normal, conductive course like we have seen in the strain sensor. Here you just need to inlay the yarn, because we don't want this yarn to make contact with each other. So the more length of yarn you put that within the structure, the more it will be good. Okay. So the concept of temperature sensor is basically, this is coming from one of the very important sensor we find in the commercial market, which you can see in bottom side, which is called RTD. This is the normally, so the same concept was used to develop the textile based sensor. And as far as its positioning is concerned, you can see that under the armpits, along the mid axillary line, because this is the best place. And this is normally we use, the normal standard thermometer we can also use to detect what is the temperature of human body. Right. So this chart will give you an idea. And these are just the general guidelines. If you are making ECG sensor, so what are the broad guidelines which you need to consider? Okay, so you can see that the geometry of all of three sensors are quite different. The elastic yarn requirement is quite different. We need elasticity in the respiration because we need a recovery. And similarly, the sensor placement, this is also quite different. So what I mean to say is that, so these are just example of three different types of sensor. If you, let's say if you are designing hydration sensor, if you're designing, let's say, a strain sensor for a specific application, then you have to consider that requirements from the application point of view and then design it accordingly. Right. So although I have mentioned that for last 20 years, the research is going on, but still you have not seen these products are available commercially in the market. There are very few products because there are challenges involved. Okay. The challenge is we don't have standards. You will not find any standard. You will find standards for normal sensors. You will find standards for conventional textile, but there is no standards for the textile sensor, E-Textiles. And then of course, interconnection, when you connect the sensors with data lines, flexibility, washability, battery powering issue, movement artifact. This is also, quite important, because movement means when a human body is moving, so the sensor contact will, so it will lose a sensor contact. And when a sensor loses the contact, it will affect the conductivity and the signals. So how to design sensors in a way that the quality of contact is there. It's not losing contact during the movement and all that. So these are some of the challenges. And of course, reproducibility. We can produce 100% ditto copy of electronic components of sensor, but we cannot do the same with the textiles because we have got inherent variations in it. And then of course, there are some telemedicine, social issues, and consumer concerns also, which needs to be considered. Right. So One thing which I would like to share here, that because yesterday there was a discussion going on regarding the modernization of curriculum, especially for the design students. I'm not sure that if something like this has been taught or practiced here in this PFID. So you may add, for example, you are talking about, we can include the artificial intelligence. We can, so this is also the advanced area. And it's not the responsibility of textile engineers to work on that field. Worldwide, I've seen that fashion designer, textile designer, electronic engineers, electrical engineers, biomedical engineers, they're all working in collaboration to basically design solutions for the mankind, okay, so that the quality of life could be improved. So I would say that if this is not there in your curriculum, at least you can give the projects to the students to work on that, because when we are designing something, during the prototype stage, we don't have the expertise for that, because the placement of the sensor, the fitting of the sensor, and the aesthetic of the apparel, all these parameters, will be well taken care by the fashion designer. So I would end my talk. If you've got any questions, you may ask.
Thank you, Professor Dr. Mohammed Daud, for sharing with us the future of technical textiles. I now request session chair, Professor Dr. Tanveer Hussain, and co-chairs to present the souvenir to the keynote speaker. Yes. Okay.